All right, let's go ahead and pray. Dear Heavenly Father, we just thank you again for the day. Thank you for the blessings you've given us. Thank you for this class. I just pray you may help us in this class, Lord, as we talk about reasoning this chapter. Help the students to think clearly as we think about reasoning. Just guide and lead in everything we do. In Jesus' name, amen. All right, we are on page 89, section 2.2. It is the section that we are on that deals with conditional statements. Conditional statements. Conditional statements are exactly what they say. They are statements based on a condition. We've had them all through our lives. You know, a lot of times friends will say, hey, I will do this if you do this. Which is a conditional statement. A conditional statement has two parts. They are a if-then statement. An if-then statement is a conditional statement. We're on section 2.2. Say for instance, we could have a conditional statement. If it rains today, then the soccer game will be canceled. Is a conditional statement because it has an if part and it has a then part. Conditional statements. We can change all our definitions. Most of our postulates and most of our theorems will be if-then statements. We have a hypothesis, which is the if part of the statement. It's usually designated with a P. Then we have the conclusion part. It's the then part, which was usually signified by a Q. We would see our conditional statement if P, then Q. We will also see it this way, P, arrow, Q. This is the way you probably see it most often. P, then Q, which is our conditional statement. So a lot of times we will have our conditional statements. We can make any statement into a conditional statement almost. But we can make up a truth table or truth value of our conditional statements. Let me get the marker here. We're going to make this little box. So take for instance here, we take any conditional statement and have it in an if-then statement. We can have a truth value of our conditional statement. This column is for my hypothesis. This column is for my conclusion. If my hypothesis is true and my conclusion is true, then my statement is true. The next one, if my hypothesis is true, my conclusion is false, then my statement would be, say for instance, if it rains outside, then the game will be canceled. I look outside, it's raining, but we still have the game. So was my statement true or false? It was false. If the conclusion is false, my statement will be false. Truth value. If it rains outside, then the game will be canceled. Or look outside, it's not raining, but we get the game is canceled. Is my statement true or false? What do everybody think? Double check something here real quick. Hold on just a second, I'm myself confused here for a second. It will be true. If the conclusion ends up being true, then the statement will be true. Okay?
Even if the condition is false.
Even if the hypothesis is false, if the conclusion ends up being true, then we're going to be true. Alright? Next one. Hypothesis false, conclusion is false. Then my statement would be true. If it's raining outside, then the game will be canceled. Look outside, it's not raining. The game did not get canceled. So therefore, the statement would be true. Here's another one. If it is your birthday, you will have cake. Right? Today is your birthday and you had cake. Statement true or false? True. Alright, it is your birthday today, but you didn't have cake. Is the statement true or false? False. It's not your birthday, but you had cake. True. Alright? Because did you have cake?
Yes.
Yes. Didn't matter if it was birthday or not, you had cake, so the statement was true because you had cake. Alright? It's not your birthday, you do not have cake. True. Because the condition was, if it was my birthday, and then I would have cake, but it wasn't my birthday and I didn't have cake, so that made that statement true. Okay? So our truth value on our conditional, if then, when is the only time my conditional going to be false? Correct. Correct. Every other time is true. Or every other time is true. That's dealing with my conditionals. Now there's three other statements, if-then statements, that we're going to look at. We have the converse. The converse, we switch the hypothesis and the conclusion. The converse would be Q, then P. So my conditional was, if it's raining outside, then the game will be canceled. Well, the converse of that would be, if the game is canceled, then it's raining outside. If the game is canceled, then it's raining outside. Would be my converse. I'll write this up here. raining outside, then the soccer game is canceled. So my converse would be, if the game is canceled, then it is raining outside. Alright, so when I look at this statement, if it's raining outside, if the game is canceled, then it's raining outside, would that be a true or false statement? Well, it would depend. We look outside, it's not raining outside. I'm sorry, we look outside, say that back. We find out that the game was canceled today, but we look outside and it's not raining. Is that a true or false statement? False. Alright, find out the game is canceled and we look outside and it's raining. Is that a true or false statement? True. Well, both the hypothesis and the conclusion was true. Alright? The game wasn't canceled, but it was raining outside. True or false statement? The hypothesis was, what did I say? I forgot what I said. The game was not canceled, and I look outside, and it's raining outside.
It hasn't been canceled yet.
Hypothesis would still be true.
The conclusion was true, the hypothesis was false, so that makes the statement
True.
true. Or then it goes to the game was not canceled, and it was not raining outside. Statement true or false? True. Okay? So we had the converse, we just switched the hypothesis and the conclusion around. Alright? So that's the converse. The inverse. Would negate the hypothesis in the conclusion. Would negate the hypothesis in the conclusion. Alright? So we're going to take the conditional. If it is not raining outside, then the game is not canceled. The inverse, we negate the hypothesis and the conclusion. We negate the hypothesis and the conclusion. Excuse me? Not. Yeah. Or if it was not to begin with, then we make it positive. Not. Take for instance, if the hypothesis, if it was not raining outside, the negation would be if it is raining outside. So we take the not away. Does that make sense? Just the opposite, yeah. It either is or it is not. If it is not, when we negate it is not, then it will be. If we negate it is not, it will be it. Yes. Just like two negatives make a positive. Okay? And then finally, the contrapositive is negating the converse. If the game is not canceled, then it is not raining outside. So we got the conditional, we got the converse, we got the inverse, and we got the contrapositive. Make sure you recognize the symbols. Because it's this is my conditional. Not P, then Q. My converse will be
You then not you.
Q, then not P. We just switch the hypothesis and the conclusion. My inverse will be
E then not Q.
P, then not Q. Then my contrapositive would be
Not Q then B.
not Q, then P. All right, so let's look at some examples. So here's the definition. A pentagon is a polygon with 5 equal sides. We want to change this into a conditional. We want to change this into a conditional. Right? So Caleb, what do you think?
If a polygon has 5 equal sides.
Aaron?
Polygon has 5 equal sides, and then is a
A polygon is a pentagon with 5 equal sides. What's the conclusion in this statement? The 5 equal sides is the conclusion, right? So we want to make sure in our conditional that's the conclusion. Correct. If a polygon is a pentagon. Then it has 5 equal sides. So there's my conditional. What's my hypothesis here? What's my hypothesis? Is a pentagon. What's my conclusion here? Okay? So what would be my converse? What would be my converse?
If the polygon has 5 equal sides, then it's a pentagon.
A polygon has 5 equal sides, then it is a polygon, a pentagon. What's my inverse?
Are you trying to negate converse of the thing, or are you trying to just,
Where the inverse negates what?
negate, P and Q?
Okay?
Are you doing like the P and Q with the converse, or the original?
Well, which one does the definition say?
P and Q
Conditional.
will be if a polygon is not a pentagon, then it is not.
A polygon is not a pentagon. I really gave that wrong definition, but I'll change this definition a little bit. I don't have any confusion. Regular. Regular. Sorry. Excuse me? Because a pentagon doesn't have to have 5 equal sides. A regular pentagon will have 5 equal sides.
So then what is the regular polygon system involved with the regular pentagon system?
Excuse me?
Some of those it's a regular pentagon, some it's a regular polygon, so what's a regular polygon?
Oops, thank you. Making a bunch of mistakes here.
You're already at like 10.
Pretty good, huh? Oh, we didn't write the first time, we'll make all the other ones. There we go. Thanks for catching that. But a regular pentagon has 5 equal sides. Just a normal pentagon would just have 5 sides. Then there's a contrapositive. Would be what?
If the polygon does not have 5 equal sides, then it is not a regular pentagon.
So let's look at this truth table. Alright, so when we have P and Q, we always have true, 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 false, false, true, and false, false. So we already know from the conditional, if the hypothesis and the conclusion is true, then it will be true. The hypothesis is true, the conditional is false, then it would be false. If the hypothesis is true, false, and the conclusion is true, then it will be true. Hypothesis is false, the conclusion is false, then it would be true. Okay? When we negate, everything changes. So if the hypothesis was true, but we negate it, now it's false. Now it's false. False, true. True, false. True, true. So when we look at this, the inverse would be what? False. Here would be true, the conclusion is true. Here would be false, the conclusion is false. Here would be true, because the two hypotheses and the conclusion is true. Yes?
So for the first half, the bottom one, false, they're both conclusion hypothesis are false, and makes it true. And why for them negate, they're both false, why is it false?
I don't know, why did I do that? Alright, false, false is true. Here, keep count.
No, it's too many.
Alright, yes, anytime the false hypothesis and conclusion is false. When will, anytime the hypothesis and the conclusion is false, it will be true. When will my conditional be false?
When the hypothesis is true, but the conclusion is false.
Alright, a true false would make it false. Anything else is going to be true. Anything else is going to be true. Okay? Now we're working up to truth tables that get pretty in-depth. But again, this is the one you need to remember. And this one. When will I be false? When the hypothesis is true, conditional is false, my statement is false. Everything else is going to be true. Everything else is going to be true. All right, you're working on page 93. And that is 5 through 41 odd. 5 through 41 odd. Good evening.